Hello, today we're going to be going over objective 13, factor in trinomials in the form of x squared plus bx plus c. So when you're factoring trinomials, a lot of times this will just take practice. You really have to think it through. You have to know what you're looking for, what your b value is, what your c value is. But with practice, you'll get it. So let me do some examples that I think that'll help you out. So if we have x squared plus 5x plus 6, let's take a look at this trinomial. Now, if we want to factor this out into two binomials multiplied by each other, we know that we have a 6 here and we have a 5 here. So you're going to be looking for two numbers whose product equals 6, but whenever you add them together, their sum is equal to 5. So if we take a look at 6, we know that we can have 6 times 1 equals 6, but 6 plus 1 is 7, so that's not going to work. So we know 3 times 2 equals 6. Oh, look. Well, we also know that 3 plus 2 equals 5. This equals 6, and then 3 plus 2 equals 5. So that may work. So let's take a look. So I always just do my parentheses out of my binomials. Your x, you have an implied 1 here, so it's x and x. And then we want 3 and 2. Well, because we have both positive signs here, we have addition, x plus 3 times x plus 2. If you want to double check yourself, you can do the FOIL method. So you would have x squared plus 3x plus 2x plus 6. So if you solve that out, you get x squared plus 5x plus 6. And that does indeed work out. So your answer is x plus 3 times x plus 2. So let's take a look at another example. So if we have another example, we have x squared plus 11x plus 18. So here we want the product to be 18, and we want the sum to be 11. So product 18, sum 11. So of the 18. So let's take a look at it here. So 18. So we know that 6 times 3 equals 18, but 6 plus 3 equals 9. So that can't be it. So 9 times 2, well, that equals 18, and 9 plus 2, oh, look, that equals 11. So then we have x plus 9 times x plus 2. And if you do your FOIL method again, you'll find that that will equal x squared plus 11x plus 18. Now let's take a look at a slightly different example here. Here we have a squared minus 10a minus 24. Oh, we have minus signs here. Instead of plus, we have minus and minus. Well, is that going to change anything? Well, it certainly does, because now you want the product to equal 24, but you need the difference to equal 10. And the reason why is because the only way you can get a negative here of a product is if you have a positive times a negative. If you had a negative times a negative, well, that would be a positive also. So you need the difference to equal 10. Well, let's take a look at 24. Well, we know 8 times 3 equals 24, but 8 minus 3 equals 5. Well, that's not going to work, so we can't use that. We know that 6 times 4 equals 24, and we know that 6 minus 4 equals 2, so that's not going to work. Well, we know that 12 times 2 equals 24, and 12 minus 2 equals 10. Oh, well, that'll work. So you have 12 minus 2 equals 10, but in this case, the 10 is a negative 10, so we're really going to want negative 12 plus 2 to give us a negative 10. So if we put our parentheses down, we have A, we have 12, and we have 2. Well, because we know that the 10's negative, we want the negative to be with the 12 and the positive 2. If you do the FOIL method to double check yourself, you have A squared minus 12A plus 2A minus 24. So you have A squared minus 10A minus 24, and that works. So this then is your answer. Hope you enjoyed the video. Thanks.